Here it comes. Here's where this chapter changes gears. Let me lay it out for you. This is the lesson we really want to do in this chapter. When we go to do this lesson, we look at and we go, what have we taught them from grade 9? And we realize we haven't taught them how to find length of a line. Pretty straightforward, actually, if you know the formula. We haven't taught them how to do midpoint. Also pretty straightforward. We have taught them slope, though. So we didn't have to teach slope here, but I'll review slope as we go along. Here comes the review of the things, the weapons we need going into this lesson. It's called classifying and verifying geometric figures. It's okay if that title is like, I don't know what you're talking about. That is totally fine if you're at that point right now. The learning goal says, use analytic geometry. Ooh, sounds fancy. Well, it is. It is. Analytic geometry is fancy. But our analytic geometry means find midpoints, find lengths, find slopes. That'll be step 1 for us. So don't let the phrase analytic geometry intimidate you too much. To verify properties of geometric figures. Okay, well, before we get out of hand and know what all that means, let's just get our basis down again. Analytic geometry uses the xy axis, algebra, and equations to describe relations and positions of geometric figures. That sounds scary. But here's what you need to know going in. All right, so if you're worried about that title, here's what you need. Parallel lines have the same slope. I know there's more to parallel lines than that. I know there is. There are two lines that never meet. Yeah, but for the purpose of this lesson, that's what we really need to remember about parallel lines. They have the same slope. Hopefully that's like, yeah, okay, I'm okay so far. Perpendicular lines have, and I'm going to do the fancy phrase, and then I'll get someone to shorten it down for us. Have, what's the fancy phrase here for perpendicular slopes? Negative reciprocals. Have negative reciprocal slopes. But if negative reciprocal is a phrase that is really too much for you on a Wednesday, or too much in general, what are you doing with the slopes? Let's just make a note for ourselves. If we're going to use this as a reference page, what do you do to the slope if someone doesn't understand the phrase negative reciprocal? What two things have to happen? Flip and change sign. That's perfect. Flip and change sign. So when it says negative, it's not saying make the slope negative. It's saying put a negative out in front of your slope. If there's already a negative there, now it'll be positive. If it was positive, now it's negative. If you want, the rise becomes the run, and the run becomes the rise, and that's what makes it perpendicular. Length of a line. Oh, well, length of a line. We have this. Hopefully, it's like you've done enough where when I write this, you're like, yeah, got it. And if you don't, well, friends, the timing of March break is actually pretty good here for you. You better get this worked out. That's got to become automatic. For what I'm going to teach in this lesson, which is sort of difficult to use these things, the weapons better be ready. You better be able to go, wham, got that. And the other thing we'll need is slope of a line, which again, hopefully is like, yeah. As soon as I write it down, you're like, yep. I know that one. I know what to do with that one. No, not what to do with it. Maybe you're not sure what to do with it. But you know how to do it when asked. That's what we need so far. All we need right now is I can do this when asked. Yes? I'm going to add one more point, one more thing at the bottom as sort of a hint for later in the lesson. Okay? I'm going to add midpoint down there on your reference page because, and maybe that's just too easy. I don't know where you're at with this. Maybe you just think midpoint is just the easiest thing ever, and you don't even need to write that formula down. But let's just have it all together on one page so we have all our weapons ready to go. There's another weapon we're going to need here, is our brain. See, math is weird. Sometimes I believe there's not a lot of thinking in math. If I just walk up and say, find the length of a line, and you know the formula, there's not much thinking. You just plug it in and get the answer. This lesson's the opposite, where it's like you stare at a question, I'm not sure what to do, and you really got to think through all the weapons you have and how to use them. That's what's coming. In 7 pages. Yeah, I always look up here, page 1 of 7, so I know. In 7 of these slides. It's not 7 pages for you. Yeah, 7 slides for me. I shouldn't have said 7 pages. Yeah. Well, I pause for questions, but I don't know what question you'd have right now. Maybe besides, well, I'm not really caught up in homework. I didn't know that was the length formula. Well, you better get caught up. If you're going to be able to do this stuff, get caught up. Yes? More time to copy those down? It's nice. You have a nice reference page now that you can go back to. Here's some other information that I hope you know, but if you don't, here it is. Here's me telling you about it. But I'll ask you. Let's get you involved. Equilateral triangle. What's an equilateral triangle?
All the sides are equal?
Yes, a triangle where all sides are equal, and here's me now doing some great teaching. Maybe you didn't need me for that. It's sort of in the name. Equilateral, it sort of sounds like the same. But for the purposes of our lesson in this chapter, we better put another word there. All sides are equal length. Yes? Not slope. Yeah, equal distance is another good word there. Length and distance, for now, are sort of interchangeable. Yeah. But I put that up there because that's the important qualification, is equal length. And maybe that's obvious, but that's the kind of thing we got to be thinking about if we're going to do what's in this section. And then a sketch. Well, you go over here and you draw a triangle that all 3 sides are equal. And maybe you look at mine and go, they don't look quite equal to me, Mr. Todd. I didn't get a pen out, or a ruler out and carefully measure them. How do we indicate to everybody that they are the same length?
You can add like a single line.
Yeah, a single line, like a slash. And that's how we indicate in math that those sides are equal. It doesn't matter if my diagram is perfect or not. Yeah, I can just let everybody know this way that those sides are all equal. If you haven't seen that before, well, that's fine. That's the way we do it. It's a nice, easy way for everyone to look at that and go, oh, they really are equal. They're not like sort of equal. They're not like look like they're equal. They are truly equal. Okay, good. Isosceles triangle. Okay, let me start the sentence for you. A triangle where, and I'm going to add the word only. Yeah, only, because somebody might, if do you have one of those friends that's like the technically person? Well, technically in equilateral, 2 sides are equal, but also, okay, yeah, all right. We'll get them right here. Where only 2 sides, and I think I interrupted you. I didn't do it on purpose. I should have waited to see if you used the extra word here that we need. Were you going to say it? No. That's honesty for you. She could have totally lied there and got away with it. Where only 2 sides are equal length. Let me just add a little hint about this lesson. Here's my teaching, because maybe you don't need me for that. Maybe that could have came out in a video. Maybe you could have looked that up on the internet. You didn't need Mr. Todd for that. Here's my teaching. For equilateral and isosceles, I care about the lengths. I don't care about the slopes. There's my teaching. Yes? So if we're trying to look for these type of triangles, we'll be looking for lengths, not slopes. Sort of foreshadowing there that, ooh, when do we care about the slopes? Yeah, coming up. Sometimes we'll care about the slopes instead, and that's where the thinking is going to come in. Scalene. A triangle. Let me get the sentence going, and I'll get someone to help me fill it in. A triangle where all 3 sides are unequal. Perfectly good. I would totally mark that right. I'm going to write where no sides are equal length. Not equal slopes. I don't care about the slopes. I mean, the slopes might come up, and they're going to come up in just a second here. Yeah? Oh, I didn't do the pictures. So excited about my explanation that I didn't do the picture. So I need isosceles here. So for isosceles, what I do is I make it really tall in my picture. When I'm trying to draw an isosceles, I go really tall. So I go tall and thin so that everybody can see plain as day that that bottom side is not equal, and then I just have two slashes there to go, those two sides are equal. That's what an isosceles is. And there's different ways you could draw the isosceles. You could make it lower and wider. You know, there's options there. Yeah, just two dashes only now. Oh, we'll get to that in just a second. Because if there's, it doesn't really come up in triangles. But if there's four sides, and these two are equal, and these two are equal, then we'll need slash and double slash, or else we'll get confused. You'll see, it won't come up in triangles. Triangles, we won't need that, but you're right. As soon as we get to four-sided figures, which we're going to do in just a minute, we might need double slashes, okay? Scalene. Well, scalene's weird because you got to try and draw it so that they don't look the same. But sometimes I have trouble drawing a triangle where two sides don't look the same. So that's why the important qualification. It's got no slashes. That's how I know it's a scalene. It doesn't have little slashes on it, okay? But then a question comes up, and they draw a triangle, and they say, ooh, find out what kind of triangle it is. And you find out it's an isosceles. Then you can put the slashes on, yeah? So that's a little confusing when you get given a picture of a triangle. But as that one sits, we don't know because there's no slashes. Yeah? If we knew, we'd put them on there. Okay, a right triangle that's scalene. See, up till that moment, I again give you permission to be totally bored with this lesson. At this point in the lesson, you're like, okay, so far you've added the word length. And these triangles I already knew about. I'm not sure you've done much of anything today, Mr. Stottenberg. I know, it drops like a hammer here in this lesson. And on the last example, it's all of a sudden like, how do I do this? All right, right triangle. A triangle where, well, I'll put the first part, no sides are equal length. Okay, so that, because this one said it's a scalene. But now I need somebody clever to try to put into words what a right triangle is in terms of the stuff we're working with. If you don't give the good answer for today, if you just give a good answer from up till now, well, yeah, we can work with that. But let's just see what happens. 190-degree angle. That would be the definition you know, okay? How can I take that information with 190-degree angle and relate that to what we're doing and how we're looking at it? I'm not changing what it is. I'm just adding on to it. If it's a 90-degree angle, what relationship will be going on there between the two sides?
If they're like the same length, then it's going to be isosceles. If they're different lengths, it's going to be scalene.
Good. He's talking about the lengths. Absolutely. To decide between scalene and isosceles, we're going to have to do the lengths. There's my first real sentence of teaching today. Really. If you want to decide if something's isosceles or scalene, you're going to have to do the lengths. But how are we going to decide if a triangle's right-angled? Using the weapons we have. 90 degrees. Absolutely true. Nothing false about that whatsoever. So whatever I say next, don't take it that I'm like, no, that's not correct. I'm just trying to go, and so that means the two lines will be perpendicular. That's the other word for it. And maybe you didn't care about that word up till now. But now a new word can come in where no sides are equal and two sides have perpendicular lengths. No, that's not right. They don't have perpendicular lengths. They have perpendicular slopes. There's the word I was digging for. And I'm going to underline it as well. So my second really good sentence of teaching today. If you want to know if a triangle's equilateral, isosceles, or scalene, you need side lengths. If you want to know if it's right-angled, you're going to need the slopes. I'm not saying that's good news or bad news. That just is a different way of thinking. You're like, oh, I want to know if it's right angled. I'm going to have to find the slopes. And we're going to do some of that. I'm coming up in that lesson here. So let me draw this thing. I think I can draw a right angle triangle that's scalene fairly easily. I just make that side short, make that side long. And now I get my right angled scalene triangle. Well, hopefully this one will be easier for us now that I've done that one and you know what words I'm looking for. Maybe someone wants to take a shot at the whole thing. Yeah, the whole sentence that goes in there. I didn't add anything today. I think you're good. If you need attendance sheets, let me know.
No, I got 1,000 now.
Yeah, good.
Can you send me this whole thing like you had it printed out? It's like from 1,000 years ago. Like, if you can't, don't worry about it.
Yeah, probably.
Or I can maybe.
Because I was
ask
the
her.
one who photocopied it originally, yeah.
Maybe I can ask her right now and see if she can send it to me because there's like a couple of kids.
I'll
that-
flip through. If you don't see it in 5 minutes,
Yeah?
it's going to be the end of the period before I can get to it.
I know, right?
Well, as I'm doing this, I'll flip through my emails and maybe forward right in. Yeah. I'll take a shot at it.
Thank you, I appreciate that.
Two things at once. I'll be the cat in the hat, you know? I'll be like,
Right? Good luck.
who wants a shot at this full sentence? Doesn't have to be perfect. We got to get close. Ellie, what do you like? Hold on. Hang on. Let me write that down. A triangle where only, do you need the word only in there? I don't know. We're just trying to make sure that somebody doesn't catch us on a technicality there. Where only two sides are equal. Did she use the word? Did you use the word? What's the word I want? Length. Okay, keep going. I'm ready. And two sides have perpendicular slopes. Yeah. Maybe just now on that sentence was the first time in this chapter you went, oh, this is going to get interesting now. You know, it's going to get a little complicated. I got to keep track of what I'm looking for. Maybe you're still unimpressed. Okay, that's great. I'm happy if you are. Nothing will make me happier. So to draw one of these, then I got to draw these two sides about the same length. I don't have to draw it perfectly. I don't have to measure them with my ruler because I'm going to put the little slasheroos on there. Am I? Yes, I am. I'm going to put the little slasheroos on there, and now everybody knows, yes, this one's isosceles. Okay, here's my third great sentence of teaching today. If we just want to know if they're equilateral, isosceles, or scalene, we'll need the lengths. If we want to know if it's a right triangle, we'll need the slopes. If we want to know if it's a right isosceles triangle, we're going to need all the lengths, and we're going to need all the slopes, and then we're going to have to think. We're going to have to do some thinking. It won't be much thinking, but you're going to need all the information. That's my job the rest of the way is to teach that. So that's three-sided figures. Now we do that whole conversation for four-sided figures. Oh, wait. And two sides have perpendicular slopes. Is it okay? Do you need more time? Here's your reference sheet. Between now and whenever the test is, that info's got to get in there. It's the perfect. Has anyone ever used Quizlet before? Quizlet is electronic flashcards. Handy stuff. And I believe shareable. Has anyone shared? Yeah? So one of us could make up flashcards here and share them with all of us. Maybe I would give, maybe that could be a bonus assignment to make out Quizlet cards and find out how to share them with the class. If you're interested in that, several people can do it. We can look through the cards. We can combine the card sets. Oh, this is fun. I love this idea. I just had that idea right now. I've always wanted to do that. And you guys seem like an Intuit group enough that maybe this is the time. Well, you let me know if you want to be one of the leaders on this. Quizlet. Here, look. Four-sided figures, things get more interesting. I'm hoping that three of these words are not new to you. I hope most of you know what a square is. I hope most of you know what a rectangle is. And I hope parallelogram you've seen before. It means the opposite sides are parallel. Maybe the word rhombus hasn't been used too much, but that's the fourth one we need. Okay? Okay, here we go. Which way do you want to go on the table? You want to go horizontal or you want to go vertical to fill these in? Vertical, he says. I like that. It's a little more challenging. Vertical's a little more challenging. Let's go vertical. I don't know. We could do a Zamboni thing. Do you want to do the Zamboni thing where we just go around and around and around? Just pick random spots? Or maybe you could pick a random spot. Maybe you want to look at any box. You get to choose it Jeopardy style. You'll be like, rectangles for 200, please. And then you can tell us what to fill in that box. I like this. You get to choose anyone. You can choose a difficult one or you can choose an easy one. Who wants to choose one of these shapes and fill in what we have to talk about? Go, yeah, tell me. Rhombus for perpendicular sides. He might be really clever, friends. He might be really clever. It depends on what you say next. Do you know the answer? Oh, he doesn't know the answer. Okay, good. He's picked one that's real nice. Look at the rhombus and look at the perpendicular sides. How many perpendicular sides does a rhombus have? Are they perpendicular? Look at them. There's some parallel sides, but is there any perpendicular sides in a rhombus? None. Now, you didn't phrase your answer in the form of a question, so I'm sorry. That's incorrect. The answer here is, what is none? Now, if that's a little tricky for you, oops, I'm on the straight line pen. If that's a little tricky, you're like, I don't quite understand that. Hold on. As we fill in the table, there'll be things that happen where you go, oh, I get it now. Who else is going to play Jeopardy today on this board? Josh, what do you got? What, you got an easy one?
Easy one, square for side length.
Square for side lengths. He's picked off an easy one. Yeah, good. I like it. Square for side lengths. What's the relationship with the side lengths in a square? All same, yeah. All the same. Good. He's picked off an easy one. But his picking off an easy one might lead you to another one. Maybe you want to go horizontal from there. Maybe you want to go vertical. Or maybe you're like, no, I'm going way over here. Yeah? Sports figures for 800, please, Alex. It's not Alex anymore. What's the guy's name that does Jeopardy now? Who knows? Well, they were switching between two people, but now it's just one guy now. The guy who won so many times. Will Smith. Wasn't Will Smith. Ken Jennings, thank you. Did you look it up? Yeah. She's so fast on the Google. Right back in the holster. Remember that for a while? Phones in holsters? It was so cool for a while, and then it was uncool immediately. Yeah. All right. Where do you want to go now?
Rhombus for side lengths. They're all the same.
Rhombus for side lengths, all the same. Okay, now that's important and relates to what this lesson's all about. If you just find all four side lengths, and those side lengths are all the same in a four-sided figure, you'd be like, okay, it's either a square or a rhombus. Okay, so this is starting to come together now about what we're going to have to do to accomplish all of this. What else you got? What do you want to do? What's next?
Parallelogram for parallel lines.
Parallel. Okay, yeah. Got to phrase it carefully though. Yeah. What's that? Parallel lines. What parallel lines are there? No, they're not all well, maybe they are. It depends on what you mean. They're not all parallel. That is, these sides aren't parallel with those sides.
Yeah.
Yeah, you knew that. So we just need a little bit careful phrasing here. Two pairs. Okay, and I'm going to go with opposite sides parallel. Well, that's saying the same thing as you, but that's just me jumping in, and I think phrasing it in a way that will help you as you're doing these questions. Opposite sides are parallel. If you want two pairs of parallel sides, yeah, that would be another way that I could say that. But I'm trying to do it in the most compact manner I can. I think that's helpful the way I phrase that, but Maybe not. Maybe you'll decide that the phrasing should be different here. How are we doing here? How many do we have to do here? 4, 8, 12, 16. We're only up to 4. That's okay. We'll take our time here. We got time. Good.
Square for the perimeter.
Square for the perimeter. Yes?
That'd be one side times 4.
Yeah, you take one side times 4. I'm going to write perimeter equals 4, and I'm going to write a small s there. And I don't like s's, me personally, because my s's always look like 5s. But that's the way I see it in a lot of books. So I'll try to use that, the perimeter equals 4s for that.
Perimeter for rectangle?
Perimeter for rectangle? Yeah, a little bit different. Good, tell me.
Length plus
Yes, because they're different, right? I don't want to sidetrack us. We're going to act like rectangles. The lengths and the widths will be different. And actually, in the technical definition of rectangles, a square is a rectangle, actually. But that's not going to affect us at all. But I just mention it so that people don't think that it doesn't fit in there. Peter, what do you like?
perimeter for rhombus.
Perimeter for rhombus, yes?
Perimeter equals 4s.
4s again, yes? Because all sides are the same in rhombus. Now, this lesson's really starting to come together. I don't say that because I'm proud. I say that because it really seems like everybody's involved in listening. You go, oh, rhombus and square are sort of the same shape. Somebody like sat on the ends a little bit, and it sort of got squished a little bit. So side lengths won't do it. Side lengths will not be able to decipher between a square and a rhombus. You'll need more. Hopefully in just a second you're like, oh, I know what the more is. There's another weapon we have. Okay, we're doing good. What's next?
Parallel sides for a rectangle, which would be opposite sides of
Same. Now look at this is you should be happy and sad all at once. You're like, I'm starting to get this. But you're also like, oh, this is going to be some work because if I just do slopes and I find out opposite sides are parallel, I don't know if it's a parallelogram or if it's a rectangle. You're like, I can feel the trap closing here about what work I'm going to have to do on every single question of these.
Perimeter for parallelogram.
Perimeter for parallelogram, yes?
2 length plus 2 width.
Yes, and we won't get too upset about whether it's called length and width. Sometimes we end up calling them base 1 and side 1. We don't care. Length, there's 2 different types of sides, so we got to go 2 of these plus 2 of these. Yeah, good. This is going well, very well. Who wants another? Where we got to go? If you want in, there's only 7 left. Have I worn you out?
perpendicular sides, parallelogram.
Perpendicular sides, parallelogram. Good. What do you like?
I just like the word parallelogram.
He just wanted to be able to say parallelogram. I like parallelogram because it's got all those L's in it, and all the L's look parallel, and it's parallelogram. I don't know if that was on purpose or not, but that's the way it worked out, and that was good. But how many perpendicular sides? Are there any perpendicular sides in a parallelogram? No, none. Now, there is a technicality here. You're like, is a rectangle technically a parallelogram? And the answer is yes. But we will act like it's not. We will sort of go, we want to decipher between the 2. We want to be specific. So I don't want you to get sidetracked by that, but we will be specific. We won't just say, oh, it's some kind of parallelogram. Maybe it's a rectangle. No. We'll narrow that down and say, oh, it's specifically a rectangle.
If a square is a rectangle and a rectangle is a parallelogram, does that mean a parallelogram is a square?
No, hang on. I'm not being funny. A square is a parallelogram, but a parallelogram isn't a square.
That's what you meant to say. Yeah.
Yeah? Yeah, I think you meant the exact right thing. You might have just said it the way around. The other way around.
It's also a parallelogram.
What's that?
Is a rhombus also a parallelogram?
A rhombus is also a parallelogram. It's a specific type of parallelogram. That's what we'll be about. Specifically. You say parallelogram. I'm like, be specific. Which one? And then you decide which one. Okay? What's a parallelogram? A parallelogram is a quadrilateral that has 4 sides. But the sides don't have perpendicular slopes. Whereas rectangle and square, they will have perpendicular slopes. Ooh, I see some stress there. Good. If we're seeing a little bit of stress, it means you're with me. You're like, oh, this is going to be a little bit of a situation. I'm going to have to think it through. Good news, it's not as bad as it looks. Once you have the lengths and the slopes, it won't be that hard to decide. But you might need them all. Okay, more. What do you want to do? Side lengths of a parallel. What do you like? Side lengths of a parallelogram? Yes? What's opposite sides equal? But I'm going to add a word. And maybe now's the first time why you know, like I said about, oh, you don't want to be around actually people. You know what I'm talking about? People who are like, well, actually, you know, and it feels like I'm being like that. No, I'm trying to help. Opposite sides equal slope, equal length. No, equal length is what we're looking for here. And that's the same for rectangles, right? Opposite sides equal length. Good. Only 4 more to go. Parallel sides of a rhombus. Opposite sides are parallel. And also for squares, opposite sides are parallel. Are all 4-sided figures opposite sides are parallel? No. We've left out the general one, the general quadrilateral, where anything can be true. Yeah? You can make a quadrilateral that's none of these things, but that is a little easier to classify. We won't need all these steps. Well, we will need all those steps, but we won't find anything equal. Last 2, perpendicular sides. Here, I'm going to add a word for you. Adjacent sides perpendicular. And that's the same over here for square. Adjacent sides. Have you heard the word adjacent before? Yeah. Adjacent means beside. And we're going to need the word adjacent later in the course when we start doing trigonometry. So I introduce it here. So adjacent means beside. So the one beside it. Beside, right beside it. It's on the same side. Yeah. All right. That was good. And hopefully, if you know your square and rectangle pretty well, not too hard to jump to the 2 new shapes that are like squished versions of those. That's the way I remember it. A parallelogram is just some kind of squished rectangle. Yeah? Okay, let's actually get to it. After all that setup, we actually get to it now. On only page 4 of 7. Whoa! Longer lesson than it looks. A surveyor has marked the corners of a lot where a building is going to be constructed. I need to tell you, friends, when they're doing planning, when they're doing city planning and planning out where the buildings are going to be, where the sewage system, where the water is going to be, this is the kind of math that they do to try and figure out what's going on. As simple as this? No, but close, close. All right, so it says there's going to be a lot constructed. A lot is the property that people own to put a house on. So anytime you're on your property at home walking around, you're on your lot. Yes? So the corners will have coordinates -5, 5, -5, -5. Let me put that on there. -30, 10. -5, 25. And 20, 10. There's the weird looking lot. Let me just look. -5, -5. Yes, I don't want to make a mistake here. Ooh, there's a really big moment of teaching. Don't make a mistake here. Get the dots in the right spot or things go haywire. -30, 10. -5, 25, yes, and 20, 10. Now, it could be that as soon as I draw the shape, you've got a guess or a prediction about what shape this is. Is it a square? No, you can tell by looking at it, it's not a square. But let me tell you about a very scary phrase in mathematics that you should be very watchful for. And it's on your quiz. It's the phrase verify algebraically. And when we say verify algebraically, we mean show your work. That is, I could have probably come to you in grade 3 and said, is this a square? And you would say, no, it's not a square. Fine. But here in grade 10, academic math, we verify it. We do what we need to verify what shape this is. So what I did was, let me label all the points. P, -5, -5. Q is -310. R is -525. And S is 2010. I made boxes for all of them because I got to calculate 2 different things for every single line. What are the 2 things I need to calculate for every single line if I'm going to verify algebraically? Slope and distance, perfect. I'm going to write length, but it wouldn't be wrong to write distance. Distance is good. I like it. I love it. Yeah? I'm going to write length and slope. So I'm going to put off to the side here. Length, slope, length, slope, length. Oh, that's going to be good. Length, slope, all the way across there. And if you're like, oh, you got to be kidding me. Look how much work this is. Yeah, I know. That's why I said you got to be good at length and slope. You got to be great at that so that you can do this very quickly. So here's what I'm going to do. I'm going to do PQ with you just in case you forget how to do these things. And then maybe we'll alternate, or if somebody wants to write on my board, they can come up and write some answers. Well, let's do this together and get this done fairly quickly. Actually, I have a good idea. We'll do PQ together. Don't do anything. Then way over here, you guys over here, this whole group, you guys are going to be QR. You'll do QR. You'll compare with each other. Yep, we got it. And then maybe you'll make a volunteer to come up and write on the board. Middle, you guys are going to be RS. Yeah? And over here, this side's going to be SP. You guys really grouped yourself weird. I just noticed that now, how you grouped yourself in this class. All right, over here, SP, okay? Hold on. We'll do PQ together. Then you'll do it together. Compare with people around you. Like, yep, we got it. Then we'll share together. Okay. Length of PQ. Square root x2 minus x1 squared plus y2 minus y1 squared equals square root. Okay, what am I doing? PQ? PQ. -30 minus -5. Oh, there's no way there's enough room in here. And what's that? Is there enough room on your page? Oh, yeah. It's just on my page there's not enough. Okay. And then 10 minus -5. And that's all squared. So I get, square root -30 minus -5 squared, 625. And 10 minus -5 is 225. No, it's 15 squared. Yeah, that's 225. Equals square root 850. I'm going to double check that in my calculator because I don't want it to be wrong on your page. Square root -30 minus -5 squared plus 10 minus -5 squared yeah, root 850. Could I get it as a decimal? Yes, I could, but I like root 850, me personally. And I'm speaking as maybe a grade 11, 12 teacher. I'm like, why would you want it as a decimal? Just square root 850. It's perfect the way it is. I know what you're feeling when you see that. Okay, and then slope, oh, that's easier. y2 minus y1 over x2 minus x1. So I'm 10 minus -5 over -30 minus -5. I get 15 over negative 25, which when I reduce that is negative 3/5. Negative 3/5 for PQ. Okay? Are you ready? You guys are doing what? You guys are doing QR and comparing to make sure, yep, you all agree. You guys doing RS to make sure you all agree. And you guys are doing SP. I'm going to play around with my flip chart and see if I can buy myself some writing space while you're doing that. So if people do want to share, we can do it. I'm not sure how I'm going to do it. No, I got a plan. I do have a plan. Okay? You do that. I'll play around with my flip chart. Okay?
How'd you get 625? I got 1,225.
Negative 30 subtract negative 5. What? Negative 25, yeah? And try this. In the middle of doing length formula and parallelograms, squares and scaling, it's easy to make a little mental math mistake. And you might be like, I never made mental math mistakes before. I'm like, I know, we're using all your brain to do this. And then there's nothing left over for that. I think that's what happens in people's brains. So rely on your calculator a little more today, even than you normally would. Yes? I'm going to play with the flip chart and try and buy us some space. I got a plan. When you're sure as a group you've got it figured out, let me know and you choose someone to come be the sharer. And I'll have bought you a bunch of space. Then the rest of you can just copy. And we'll see if I do my job. Oh yes, I am very happy with the job I have done. Oh, I'm good at this job. Look at that. Is it big enough? Oh yeah. It's good. It's good. I'm happy. QR, RS, SP. When you're confident as a group that you got the two, call me over. And then come see me with the pen. The pen's a little awkward. You'll be okay. You'll probably be a bit better at it than I am.
That's 7/6.
What you get?
I did it wrong somewhere.
Tell me what's happening.
Don't know why, but I'm getting the wrong answer both.
For which one?
Both these.
Oh, let's take a look.
Not get square root of 200.
X2 minus X1. 5, negative 5. This is not negative 310. This is negative 3010. Yeah? And you know what? I hope you listen and appreciate what I'm saying. Do you see me check when I put the points up? Because I'm like, 90% chance I'm going to make a mistake. It's just copying. Once I start using the formulas, I'll probably do it right. Yeah, so watch out the copying. Do we have a volunteer over here? What are you guys? SP? You guys are feeling confident? Try it out. Now, the only thing is, that pen likes to be flat. You can't be like, see, look here. You can't be like this. You can't be like that. You got to be sort of like that. Oh, good. Oh, yeah, wait. Oh, no, that's fine. That's fine. Here, hit the pen button there. Sometimes you got to hit it a couple times. You'll know you're on pen because it says pen right there. So I think you should be good now. Yeah, okay. We feel confident over here now?
We're insanely confident.
We are insanely confident.
Like-
And you guys are QR. You're going to share. What do you got? You got RS? Okay, we're in great shape. You just have to wait for her.
Like there's so much confidence that you consider it cockiness.
We're all the way to cockiness about this. That's good. The rest of you, as she's doing SP, should either be doing it yourself or copying her work. Yes? If you're like, yeah, I'm pretty good at these, I'll just copy hers. I have confident, great. Copying's fine for the other ones you didn't have to do. You had to do one at least. I will continue to try and find that email. Yeah.
Sign my,
Yeah, did I sign the wrong spot or did your parents change their mind?
not my parents, my sister.
Oh, she moved it all around on us. Yeah, that's no problem. As soon as we finish this lesson, if we finish this lesson.
This was our history.
Found it. Look at this. Oh, I'm good. Forward. Include. MED. What's the date? What's the date? What's the date? What's the date? February 25th. Okay.
So on this, would I just keep it at square root 850?
That's what I'm saying. But you don't have to. You can be totally like, you're scaring me. I want the decimal. Good. But isn't square root 850 nice compared to decimal? That's what I'm trying to get to is like, maybe just leaving it as root 850. If we don't need the specific number, if we're just comparing with other numbers, then I'm looking for square root 850. Yeah? So, but whichever way, the decimal's fine. I'm not trying to burn you. All right. Who's up? Who's up? Make sure you're in the right slot though. Yeah? And the pen is a little persnickety. It's got to be sort of straight up. You can't be off to the side or something. It's like sort of straight up like that, okay? And don't drop the pen, because those pens are my whole life, man. Oh, come on. How we doing? Oh, is it being persnickety? You don't have to press anything. Yeah. What's happening? You see? Yeah, just really sort of like that. Try again. Don't press any buttons on the side or anything like that. There you go. Yeah, just write a little faster. Is it working for you or no? Coming better now? Yeah, I like it. If you're impatient, do the calculation yourself and compare. I'm going to try and write it at the same time as you and see if it interferes. I heard that it doesn't interfere. Oh, it does. It does. Sorry, that's my fault. I was checking to see if 2 pens could work at once, and the answer is no.
What was written on the poster, like portable, it said school is important, but volleyball is more important.
This is more important.
Yeah, it said more important period. There's no way you didn't write that. Look, I was gonna say, education is important, but volleyball is more important. But no, now that I look at it, it's not your head.
I win again. Good? Yeah? Okay. Austin, you're up. Okay, the key on the pen is it likes to be straight up and down. It doesn't like to be over here like this. And so then once you're straight up and down, then it works pretty good. It's fairly slow writing, but not too slow. And you're in here.
Got 50.
Oh, that's funny. Is the pen working for you?
You still need that?
Yeah, you got it. You got it.
You already gave it a something. I erased that. Erase the eraser marks.
Yeah, yeah. Yeah, yeah, I like. Actually, what you should do is instead of going, see the square that's over top like that, just sort of put it over top like that. Okay.
Whenever I do the square root symbol, I always make it too short. It makes me really mad. That's my straight I did it wrong. All of my lines was I don't know where I put the number from. You get 80. I got 1480. 1480. Yeah. What is this number? 225. Okay, that's.
Thank you. Great work. Thank you very much. Okay. My turn to teach. Because all of that stuff, if you did your homework, all that stuff's like, more of the same, Mr. Todd. What's your actual lesson today? Here's my actual lesson. Once I have all that information, then I look at that and I go, what am I dealing with here? So we found out square root of 850, square root of 850, square root of 850, and somebody got decimals. I'm okay with the decimals. I'm not trying to put down decimals. I'm just saying, isn't it square root of 850 nice? I don't have to look at it and I have to guess how many places to round off, anything like that. So you can leave it as root 850 when you're just comparing. Did we all find that square root of 850 was the length every time? I found root 850. You all found root 850. Good. Go to your diagram now and go, whoop, 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 whoop. All the same. If the opposite sides were different, we wouldn't be able to do all the same. We would have maybe had to put double slashes on those other sides. Okay, all the same. Back to our chart now. Let's just pretend I did my homework and I found all the side lengths and I got all the side lengths the same. Back to my chart, which you don't have for the test. You're going to have to know these things. What have we done then? We have found out that it's not a rectangle because all the sides aren't the same in a rectangle. This is not a rectangle. It could be a square. It could be a rhombus. It's not a parallelogram because a parallelogram has opposite sides different. Not actually true. This is actually a parallelogram, but we can be more specific. It's either a rhombus or it's a square. It comes down to this. Are adjacent sides perpendicular? Let's look at the slopes. -3/5, +3/5. It did change signs, but did it flip? No. So the sides aren't perpendicular. After all that work, therefore, PQRS, down here, is it in the corner of your note? Yes. Therefore, PQRS is a rhombus. Now, if the question says justify, then you've got to explain here. You don't get all the marks unless you explain, because all sides are equal. And none are perpendicular. Do you see how this is different from yesterday's lesson? Yesterday we were just finding side lengths, finding midpoints, finding slopes, whatever. Now we're doing something with it and making some decisions. We need some other knowledge to put together. Okay? Do you have any questions about that? Wild example. Okay, now that we've done all that once, for the rest of the lesson, I won't necessarily go through all those steps. I'll just give you the information, and we'll do a little bit of practice on actually doing the classification from the information. Because the next one, I think I actually give you them. I go, here's the side lengths, here's the slope. Somebody already did the work for us. We have all the information, which hopefully you can do now. You can go, well, if I needed to, I could find all the side lengths, I could find all the slopes. So, can someone take a look at that, take some time to look at it, and decide what kind of shape this is? It's at least a parallelogram. Two opposite sides are parallel. Two opposite sides are parallel. So it's at least a parallelogram. But is it a rhombus? To be a rhombus, all the sides have to be the same. Are the sides the same? Yeah, so this is a rhombus. True, it's a parallelogram, but more specifically, it's a rhombus. All sides are the same. Yes. So what one more thing would I need for it to be a square? They need to be perpendicular, and they're not. They do change signs, but they don't flip. So we need to change signs and flip. Rhombus, justify. All sides equal length, but, and I'll put that on there, but no perpendicular sides. Okay? Is that okay? With 15 minutes left, how am I doing? Oh yeah, page 6 of 8. We're going to be okay. Maybe. If not, tomorrow's just a work period to work on your assignment and your homework. So if you're looking at the homework going, Mr. Todd, you're teaching the whole class here. Yeah, that's why. Tomorrow's a work period. Yeah, okay. So I don't get through the last example, we'll finish it tomorrow. Okay, what's this one? Side length 6, side length 8, side length 10. Let's just do that much for now. 6, 8, and 10 are the side lengths. What is this? Scalene triangle. Justification. No sides equal. That's what a scalene is. But we can do a little better. We can decide, is it a right triangle or not? And this one's as tricky as I could come up with. I went, okay, what's the toughest thing I can do to them to try and fool them? Is this thing right angled?
It's a right
Which ones are negative reciprocal? Oh, 2 over 1 flipped. Sorry, 1 over 2 flipped is 2 over 1. That's this one here. Negative 2 over 1. It's a scalene right triangle. XY and YZ are perpendicular. And it's okay if you're getting butterflies in your stomach going, oh, this is getting interesting now. Because it wasn't interesting for a few days there, maybe. It's like, yeah, okay, so what? Midpoint. Okay, so what? You know, length of line. Here we go. Things went crazy on us. Any questions about that one? Last one. Tony is constructing a patterned concrete patio. So in his backyard, he's got some concrete set out so he can have a barbecue, have some friends over. It's not all grass, it's a patio. In the shape of an isosceles triangle. Ooh, they're telling me. This is an isosceles triangle. On his plan, the vertices are 2, 1. Okay, friends, I hope you're good at graphing points. I hope I don't have to go over this anymore. If not, boy, you better get that nailed down. Graphing points. 2, 1, 5, 7, and 8, 4. 8, 4. Oh, I was just talking to somebody about this. Be careful to make sure you get this part right. 2, 1, yes. 5, 7, yes. 8, 4, yes. Okay, and I'm going to connect them up. Confirm the plan shows an isosceles triangle. What do I got to do to confirm this is an isosceles triangle? When I look at it, I believe by looking at it that it could be isosceles. Find the lengths of the 3 lines. Got to be done. Find the lengths of the 3 lines. Do I have enough space here? I'll go over here. A. You try it now too. We'll do it that way. I'll do it up here. You do it yourself. See if you can nail these down. Sometimes some people are still getting messed up by the negatives and everything. I'm going to go length. Oh, I didn't label the points. P, Q, R, length PQ equals. All right. Square root Oh, I love that it's gone dead quiet here. It means a lot of people are trying this. That's good. PQ. I need some people to check my work in a second here. I'm doing it without a calculator. PR. I give you time. Do you need more time? Yeah, good. Take time. I gotta watch this bell though. I want to time this just right to wrap up this lesson. What time does this bell go? 11:35. Oh, I got 8 minutes. We're okay. We're okay. Everything is fine. You're like, but B. What about B? I know B. My first curveball all chapter coming at you in B. Yeah. Oh no. Oh yeah. I'll give you a hint. No, I'll give you the formula. But then it's going to take some thunking after that. Whoa. More time to find these lengths? I'm not trying to rush you. I don't want to bore you. Did you get root 45, root 45, and root 18? And maybe you got them as decimals. Fine. But how nice is this like this? Isn't it nice like this? She doesn't like it. Okay, let's get the, what'd you get? Tell me the decimals. You didn't like it, but you kept it that way. Is that what you did? Did anyone do the decimal? What do we get? 6.7, approximately. So this one here, down here, was approximately 6.7, because we rounded it off. And then root 18, 4.2. Fine. I can live with it. But I hope you see the advantage of leaving it as a square root. Did we verify it's isosceles? Did it work out? Yes. We write something like this. Therefore, length PQ equals length QR. Therefore, triangle PQR is isosceles. And I mark it on my diagram because I'm like, there, I got it. Okay? Is it okay? This is why all the practice on length, so that you're ready for this moment. Now, friends, part B is my big matzo ball to you. It's my big ha. Huh? You're like, oh, I get all these questions right all the time. 10 AP, I'm the smartest person on the planet. I believe it. But this is going to take some thinking. It says, calculate the area of the patio. Please write down this. B. Area of a triangle is base times height divided by 2. That will help you to find this area. Your homework tonight, my friends, is to hammer away at this any way you can come up with. Anything you can come up with. And we'll compare tomorrow. That's what we'll do first thing tomorrow. I'll save this just like it is. And then tomorrow we'll come in and maybe someone will come and say, well, here's how I found the area. Oh, here's how I found the area. And we'll just compare all our ways of finding the area. And we'll talk about, hey, maybe I'd like to do it this way. Maybe I'd like to do it this way. Okay. I don't care how you do it. Find a way. That's number one. If that's all you accomplish tonight, is trying that until the tears come, good. Just get the Kleenex out. Don't cry right on your page. It smudges your work. What I mean by that is, let's show some perseverance on this. Let's act like it's not on a test. Tomorrow's not a quiz. March breaks the next day. Chill out and really look at this and go, how would I find the area of this crazy triangle? Because I thought area of triangles was easy, and it might be, but it's going to take some thought. We'll take that up tomorrow. If you get that done on your board, you can start on this. But the rest of tomorrow, after we take up the area, I'm done teaching. You'll have the rest of the period to do this homework and the rest of March break. And I've got an assignment for you to take with you that you can work on tomorrow as well. Okay? No quiz on the Friday before March break. If you're upset about the assignment, you're like, well, at least it wasn't a quiz.